Hey everyone, so this is the instructions video for project 4, excuse me. This has been switched around since last semester, so let me change those real quick. Lab 4 is exploring an unknown maze and then using algorithms to eliminate any dead ends so you take the most efficient path through the maze. We're going to be offering two versions of this. One is completely in software. You'll have to code it in MATLAB. I have some starter codes and examples. We'll go through that in your own video later. And there's also the hardware version. That will have its own video later as well. But here's just a brief overview, one of which will use the hardware version will use distance sensors to find where the walls are of an unknown maze. You'll have to calibrate at least one IR sensor, two if there's enough sensors available for everybody. This uses an infrared pulse to measure distance based on how long it takes a beam to leave the sensor, bounce, and then come back. We talked about that in lecture a bit. Here's an example calibration curve. You'll also be getting your own Excel spreadsheet ready to go. You just have to fill in your measurements using the analog read. Go into that more in your own video later. But both versions of the lab will have unknown mazes. The hardware version will use one maze in class. The software version will have 10 different mazes to show that your algorithm is robust. And I'll go into that later as well. But here for both types of the lab, you'll pretty much use the same logic. And something I've created to help you guys is the Lab 4 GUI. So if you have MATLAB installed on your computer, you can download these from either assignment. And all you have to do is come into the command window and say Lab 4 GUI in the same, as long as this folder shows that it's open. And then also this tests.mat variable has to be there. So you can just press enter there and it's going to pop up this own figure window. Just give it a second to load. Here is an example maze where the green star represents the start point, the red star is the finish point, and the arrow is where your robot is and where it's pointing. You can use the arrow keys on your keyboard to manually control these. Here I am moving the robot with my keys, and it's also populating my moves list array. So I gave this to you guys so you could have something hands-on to help you take a look at what patterns might emerge when you are trying to solve for your dead-end algorithms. So here's our first dead end. The first clue that a dead end exists, I was using the left-hand rule here. So when I came up to this square and the left was available, I went ahead and took it. So since I'm using the left-hand rule, a dead end is indicated by a double right, which we see here. And you'll have to take a look at the different types of patterns and see how you can get rid of those. So in this case, here I took this initial left into the dead end. And then I found, let's see here. Yeah, there it is. Okay, so in this case, what I would do is I found this double right. It's matched by 4 odds on either side because that's how I got into the dead end here at this spot. So normally what I would do is I would go ahead and take those and then this left on the far end. You take all those and replace it with one right instead. So now if I press enter, there, I didn't go all the way into the dead end, but now we can see there's another double right. So we take the forward on either side, the double right and the left on the end, because that's the opposite of right. That's the left-hand rule we're using. I replace that with another right. There, now I didn't go all the way into that dead end. And continuing on, now we have two Fs on either side of the dead end, and also a left on either side of the dead end. I can replace that all with a forward. Oops, not a forward. I just delete it. There we go. Now I'm in the same spot as I was before, but I never entered that dead end. So that is just from some experience of looking at the different types of patterns there are. And you'll have to take a look at these. There are 10 example mazes. Just give it a second to load. And then you can be sure to practice either right or left hand rule, whatever you decide. And just play around with it. You have to click out of any of these boxes before you can start doing the arrows again. Stuff like that. Yeah, so we have up is forward, right and left are turns, and down is undo. And then, like I was showing before, you can also edit this with text and press enter. So hopefully that helps both classes with their logic and, both lab types with their algorithm logic. And then for details on the specific hardware versus software, go ahead and check out the other videos.